Hello and welcome back, everyone, to the AAVSO How-To webinar series. The how-tos officially went on a little bit of a hiatus over the summer when we replaced them with the observing section webinars, but it's really great to be bringing this sort of instruction back to our virtual stage, and we're looking forward to another season of how-to webinars. Today, we're going to take a deep dive into the Target Tool and its technical interfaces. But before we get into that, I have a few quick announcements to make. First of all, we are running Zoom in webinar mode today. What that means is that you get access to a few special features. First, you have the Q&A button. You can find that down at the bottom of your screen. If you click on the Q&A button, then that will allow you to type in questions for our instructor. Feel free to submit as many questions as you would like at any point throughout the show. After the presentation, we will sort through your questions and try our very best to answer every one of them. You should also have down there next to the Q&A button, a button labeled CC or Show Captions. That does what it sounds like. It enables or disables Zoom's automatic closed captioning. It can sometimes be a little wonky when trying to translate technical words, and so you can decide whether it's useful or hilarious. Okay, I think that's everything that's Zoom webinar specific. So why don't we move on and talk about the AAVSO's other webinar series. So we are running another monthly webinar series sponsored by the National Science Foundation. It's entirely in Spanish, including the title, which translates to The Science of the Sky for Beginners. Each webinar introduces basic science and astronomy concepts and provides opportunities for casual discussions between presenters and participants. It's totally free and aimed at the general public, age 12 and up. The next broadcast is scheduled for September 16th, and we will continue to broadcast these Spanish language webinars on the third Saturday of each month all throughout 2023. Please feel free to spread the word about this series to your Spanish-speaking friends and colleagues. And now, back to the webinar at hand. Our 2023 How-To series is sponsored in full by Boyce Astro. We'd like to take a moment to thank and acknowledge them for their generous support. The Boyce Research Initiative and Education Foundation provides online astronomy education, observatory resources, and research experiences to students, student teams, and schools in order to learn how to perform observations, conduct research, and publish their results in scientific journals, such as the Journal of the AAVSO. Please check out their webpage to learn more about their work. All righty. Our instructor who is joining us today is a software engineer with over 45 years of experience. He has a bachelor's degree in electrical and computer engineering from Rutgers School of Engineering, as well as a master's degree in mechanical engineering from Stevens Institute of Technology. In the 1990s, he began working with NASA images from the Voyager spacecraft, which led him to discover a passion for astronomy from a software development and image processing perspective. Later, in 2015, he began building his own very impressive observatory, complete with a handmade 15-foot dome. He wrote his own software for remote control of this observatory, and when he did, he added features designed to keep him up to date on all of the latest targets and alerts from the AAVSO. In the process, he wound up becoming a true expert on the AAVSO Target Tool, learning its interfaces inside and out. Today, he's joining us to share some of that expertise and to let us in on some top tips for using the Target Tool and its API. So, without further ado, please allow me to introduce our instructor, Mark Sproul. Mark, take it away.
Let me know when that comes up.
Still loading, should be just a moment. Okay, it's loaded.
All right, thank you very much for that intro. Again, my name is Mark Sproul, and just a shout out to Cliff Ashcraft, who's been my friend and mentor for 40 some years in astronomy and helped guide me along my way. He's one of the participants out there today. And this is my bio, which she just went over all of that. A fun fact about me is I'm an identical twin. and my brother and I are married to twins, and they are 1 day younger than we are. Born the next day after we were the same year. We were married in a double wedding, and we all met studying computers at Rutgers University. My observatory that she mentioned, I gotta move this out of the way. This is my observatory. It took me 2.5 years to build that dome, 30 hours every single week, nonstop for 2.5 years. I was expecting it to take me a year. Well, I was off by about 50%. And this is what's inside of it. A 16-inch Newtonian, a 4-inch refractor, and a 3-inch refractor, all co-mounted and co-aligned so I can observe at different magnifications at the same time. My goal, my dream back in the 90s when I started was a client server paradigm for controlling system, which I've now developed. Just another view of the telescope inside my dome. And it's works as much as I done everything. I wouldn't change a thing. It worked out really, really well, except for the length of time it took to do it. And this is the pier. There's 4.5 tons of concrete just in that pier to support the telescope. So it's very, very sturdy and isolated from the foundation. And this morning at 6 a.m., I took this picture. I showed one of my moon pictures in one of my meetings, online meetings at work, and I got accused by my colleague of mooning my colleagues. So what is the target tool? The target tool is a method to access these lists of potential targets that AAVSO has been accumulating for years, variable stars and the like. And obviously way back when it was all done by paper, and it's been advancing to computer interfaces. And there are 3 ways to access it: via the web, via email, but that's just the alerts. There's a lot more than just alerts, and the programmatic interface. As Lauren said, the programmatic interface is what I get excited about, and that's what the stuff I do. And we're going to cover all 3 of these interfaces. So the data that is available, the alerts and campaigns I've highlighted at the top in red, that's the default, and that's the one that I spend most of my time on. Actually, all my time. I really haven't used any of these other databases, but this is what's available. Exoplanets is very interesting to a lot of people, and just a lot of other target lists that you can take a look at and isolate them individually. So this is the web interface, and we see up at the very top all that list that in that previous slide that you can select which ones you want. And I've currently done a cert. The 831 alert number 831 is the most recent one. And we're going to do hopefully if we have time, we're going to do some interactive with this, but this is just a screenshot at the moment. And we notice on the left-hand side of the screen, it says V102, 1082, Sagittarius. And the right side, it has a link for the alert itself. So if we click on that blue thing on the left, we're going to get taken to a web page which talks about that star, just information about that star. Pretty generic information, but all the information you would need about the star that's to being observed. If we click on the link on the right-hand side, we go to this page, and this is the description of the alert. And it's just an easy to get to web page, describes everything, and here is the text of it. And for this particular one, which just came out, this most recent one, came out a couple weeks ago, they're getting ready to observe this star with the Hubble spacecraft, and they need to get some measurements done beforehand, and they're asking for assistance, primarily in the photographic, but spectroscopic would be nice as well, of getting this star to prepare for the observation of Hubble. And this is one of the very common types of requests that comes in of we need some assistance ahead of time for Hubble or other spacecraft before we're going to actually take the time on this really expensive high power machine, so help us out a little bit. Occasionally there's even alerts for, hey, we would like a picture of such and such a star every month or 2 for the next 5 years. I've seen a couple of those, but this is a very common type. Then if you scroll down in that list, it takes you to this just more information, and there's the AAVSO variable star plotter. which you can click to and type in some information and actually get a star chart about that particular star. Kind of old school, kind of like, the paper style of doing things, but still it's part of the tool that you have access to get information about this observation. The web interface is very easy. Just type this in and type the number. This will come apparent later on when we get to my software, and something I take advantage of. Just keep track of the number, then I can get to the web page very easily. You also can sign up for email alerts, and you get the exact same information, but it comes in automatically email. This is how I started getting information and go look at it. And then I learned about the target tool and how to access it and programmatically. So you can get these. Now do not get inundated by them. This is my list back to February, averaging between 1 and 5 a month. So it's not like you're getting one every 10 a day like spam. They come in, they're not real often, and they're enough to keep you interested in, and some of them you can't do. Some of them are in the Southern Hemisphere, but every month or two you might be able to find something that you might be able to participate in if you've got the equipment. The announcements also say what they're looking for, whether it's photometric or with spectroscopy or what filters they want. So some of them you might not have the equipment to do, but it's still very interesting. Membership is not required to sign up for this email, but you do have to create an AAVSO account, which does not require membership. And then you sign up on the email page. It's very simple. You go to the page and you click the alert notices, and then you'll get these alert notices, between 1 and 5 a month. While you're in the settings page, it's worthwhile, if you're going to use the tool, to set the latitude and the longitude of your observing site. This, you'll see in a bit, will help out with the results that you get from the target tool. So now we're back to the target tool, and this time we've selected exoplanets. And we see here at the top, it shows my latitude and longitude and says the nighttime will start at what time and go to what, from 7 o'clock to 5 a.m. And we see it down here in the third column from the right. It tells us what time from our location that star is going to rise. That's why it would be important, if you're going to use this, to have that latitude and longitude of your observatory input so to configure this out and give you information that's useful. Now, once again, we have two different links highlighted in blue, one on the left and one on the right. And the one on the left takes us exactly the same place that we were before, to information about that star. The one on the right takes us to Swarthmore University to a exoplanet transit system. This is a system, it's outside of AAVSO. I have not used it. I don't really know anything about it. The only thing I know about Swarthmore is that's the home of Sproul Observatory, named after Governor Sproul from about 1850, who donated the money for the observatory. The dome is still there, but they've built a new observatory outside of town, so the dome is no longer used for observing, but it's Sproul Observatory, and that's my name, so I know that about that observatory. Other than that, again, this is kind of on your own. I don't do exoplanet stuff, or at least ways I haven't done any, so I don't really know how to use this, but this is where it takes you to. Now we get to the part that I like, and how I got involved on this is the programmatic interface. The access is through HTTPS and JSON. HTTPS is Hypertext Transport Protocol. That's what you use every time you use your web browser to talk to a web server. Now, normally you think of, okay, the web browser is going to talk to the web server and it's going to get HTML back, which is going to be your screen. Well, HTTP is much more powerful than that. Obviously, you can download JPEGs and other things, XML, and it can also download JSON. JSON is JavaScript object notation. It's a very easy to read format, which we're going to get to in a bit. And any language that has support for HTTP and JSON, you can do this in. You can also write your own. I wrote my own HTTP drivers. Well, I didn't do HTTPS, but I've written all my own JSON stuff. And there's plenty of libraries out there. And you can also do it from a command line. without any programming at all other than a shell script. And there's Python code on the web page on the API documentation, which is quite good. They do a very good job of describing how to use a Python code. It's not very long. You don't have to be a programmer to be able to use it. It's kind of straightforward. I am not a Python fan. I like C and C++, and so I did everything not using Python. I did try out the Python code and to figure out how things worked, but for what I'm doing, I'm not using Python. But what they have is very well documented on how to use a Python to access this data. So this documentation, examples of Python, the authentication is a little bit complicated, but they have it documented very well. It's a several step process to generate the key that you have to be able to sign on each time. So with each request that you send to the server, you have to provide an authentication key. And but like I said, the description on how it works is very well done, but it is a bit complicated. So I use the curl command. This is on Linux on command line. It's a Linux command that allows you to talk to servers, to download files, to do anything with all kind. It supports HTTP, HTTPS. HTTPS, by the way, is just a secure version of HTTP. It supports a bunch of other protocols. And this is the description from the man page, and Support just allows you to access the data. So the curl command is actually very simple. Curl get, then you specify the URL, and then in Linux, in a Linux shell script, a backslash means continued on the next line. So this is one big long command. But in a shell script, in a text file that's a script, you can break it up into several lines and put the backslash character to indicate that it's all supposed to be on one line. This just makes it easier to read. So the authenticate authorization, once you've generated your authorization string, you just copy and paste it in there, and you execute this command, and it will return you JSON. There's other options in the command. Back to that list of data types. The default is AC, which is alerts and campaigns, but you can specify OBS underscore section, and then specify one of those character strings up that we went over earlier in there and get just that particular data section, or you can specify all. I just leave that blank because all I'm interested in is the alerts, and which is the default. And there are several other parameters that you can pass. I don't use any of them, just list them here so that you know what they are. Not a real long list. And again, very well documented on the page. Not needed. The latitude, longitude, if you have them set for your observatory, it defaults to what is set for your account. If you wanted to then specify a location that wasn't your observatory location, or if you didn't have it set, you would need to specify that to get the information to be relevant to your location. For me, for the stuff I'm doing, I don't care about it because I'm getting all of it. I'm getting all the alerts, and it doesn't matter when it rises up because I'm going to plot it in a planetarium program. JSON, JavaScript object notation. It's a lightweight. It was designed to replace XML because XML is very verbose and hard to deal with. Very easy to read, easy to parse, and it's used quite a bit. In fact, some programs use it for their preferences file, for the settings in a program. It'll just save it out as JSON. JSON just keyword value pairs. And when you get the data, it looks like this. And I know you're going to say that does not look easy to read. And I agree with you. The one thing I wish AAVSO would do is that they would add character and line feeds to this. Unfortunately, many people that write JSON generators don't bother with that. So I've written a program that goes through here and puts the character and line feeds where they belong. And this screen then ends up looking like this. And gee, that is very easy to read. And you see that each one of those lines, targets, colon, square bracket, that means there's going to be a list of them. And the list, I think, is currently like 1,300 long, 1,300 different targets. It's got the name of the star, it's got the right ascension, the declination, it's got the minimum and maximum It's got modes and such like that. The information that you would need. And you can see on there the RA and DEC are in the second column. And that's what I read. So this is the data that I deem important, what I pull out of it. The magnitude, the star name, the red ascension declination, to know where to plot it on the screen. I also pull out the alert number, which I didn't display on the previous page, but I pull out the alert number so I can keep track of that. The data size, if you get just the alerts, it's 768K and it's 28,000 lines of text once it's broken up. If you get everything, it's 1.4 meg, 55K. Again, not very big, really easy, quick to download. It's a lot to go through by hand, but I don't go through it by hand. Let the computer do it. Now we get into the part that I like, the software. So this is what I've done, my program. This is my planetarium program in full control system that runs everything. It's all open source. I've got the link at the bottom of the page is where you can get it. It's all C and C++. Currently, it's about a little over 200,000 lines of C++ code. And it uses the Alpaca protocol, which is part of ASCOM family, but it's not restricted to Windows. I do not use Windows at all. And they came out in 2019 with a follow-on to ASCOM, keeping the same data model, but just using network communications instead of the COM model in Windows, which makes it much, much more powerful. And by the way, Alpaca also uses JSON for its data, but we're not talking about that so much in this presentation. So here is my planetarium program. Might be a little bit hard to read, but it's kind of a typical planetarium program. It's got stars, it's got constellations, it's got Messier items on it. And as you zoom in, stars appear and such. And it also has alerts. So if I tell it to display everything, excuse me. Talking too long, I gotta take a drink of water. Everything in yellow is an alert. And in this particular slide, I've just turned them all on. They normally turn on as you zoom in based on the magnitude level. If you zoom in, it looks like this. So you can see more detail. You can see what it is, what the alert number is, magnitude, what the name of the star is, and such. And in my program, you can go to a list of them, which shows you by number. You can sort by the alert number or by star name, etc., and sort by magnitude. You can get all these alerts. Again, number 831 is the most recent one, which came out first week of August about Hubble. If you double click on a line, in this case 831, it takes you on my planetarium program to that location. And you can now see where it is and say, hey, is that something I can see? I can then click up in the right-hand corner. If I click the go to button, my telescope would just go there. Just right now, just go there. So I can get to the object very, very quickly without really having to do anything. And I do all this from my basement. I didn't even go out to the observatory. This morning I woke up at 5 o'clock. The moon was out, up nice and high. Came downstairs, didn't even have to go outside. Told it to open up the dome, point the telescope, took some pictures, and went back to bed. If I hold the control key down and double click, it takes me to the web page. Remember I said about how simple the URL for the alert notice was. Well, I've kept track of the alert number, and I just create that URL, and I tell from my program, I tell it the web browser to open up with that URL, and up pops the information. So I now have from my program with some access to this information very quickly. I have a cron job, which in Linux is a way to run something periodically. Every morning at 2 a.m., it runs a script, which runs that curl command, which pulls down that data. So I have it up to date every day. And like I said, the only most I've seen is like 5 in 1 month. So doing it every day, I'm pretty guaranteed to have it. I can also go run it manually if I knew something. If I got an email and I said, oh, there's something I want to go take a look at, and I want to get ready to do it tonight, and I my program won't download until 2 o'clock, I can go run the script manually and have my program updated so I have that new information. But this is the same web page we looked at before. So I just get to it very easily. I started my observatory in 2015. I'm planning on working on some more observatories in New Mexico, and I expect to be supporting this for the next 20 years, running my own observatories, and it's all open source, my stuff, and it's of course accessing the AAVSO stuff. In summary, and I think we got plenty of time. I'm going to do some live demonstrations. The target tool is a great place to start if you want to contribute to real science. It gives you a starting point, a target, pardon the pun, targets to point at, to take information, to do something real science or research. And it has options for people like me to do the fancy stuff, which is what I've been showing. One thing that AAVSO really would like, they specifically asked me to add this slide into my presentation, is when you're using the system, you see at the top right, it says feedback. If you've got any comments, questions, problems, please send them a message. George has just in the last 2 weeks that I've been working on this presentation, I found a couple mistakes in documentation, and George had them fixed typically in less than an hour. So they're quite responsive. Really want to hear your feedback. These are the web links. Probably too much to write down, but I'm going to show you where to get all this information. This is my my Git server. The information, including this talk, if you go to GitHub /msproul, it'll take you to this page, and you've got my entire Alpaca Pi source code and the stuff, including this presentation under the AAVSO information, and my scripts. If you happen to be running Linux, my scripts to generate that stuff. So I want to open it up to questions, and I'm going to switch over to bringing up my live stuff and play around with that. But I think we can start with questions.
Wonderful. Okay, thank you very much, Mark. That was a great introduction. So let's see. Well, the first question that we had come in here is actually a bit more of a comment. I think it's quite related to what you were talking about with sending feedback through the form. So I would advise Andrew, who sent in this comment, to please send in some feedback about this. But Andrew had noted that in the target tool, the last observed column tracks weeks as its unit of, when was the star last observed. So for variables that are observed daily, the last observed says 1 week ago. It makes it seem like every star is being a bit neglected. So that's good to know about, Andrew. That makes me want to add on to Andrew's question. Mark, when you're using the API and you're getting this information, is the last observed date, I assume that comes with the API download, and how precise is that? Is that also at weeks, or does it say more precisely?
All right, I'm going to share my screen here so I can answer that better.
All right.
Desktop, and we are going to go to one. I did the right screen. Let's see, last data point. Yes, it's in Julian. We see right here. Can we see that? The last data point, that's a Julian date, which is to the day. So that's the information. I don't currently do anything with that part of the data, but it is there. Is that the question you're asking?
Yes, it is. Thank you. That's great. All right, so we had, related to that topic, George Silvis is here in the audience. Hi, George. For those who aren't aware, George develops the target tool and does a very good job of it. He says that the last observed date is updated every day. So Andrew, specifically what you're talking about, this is probably a great thing to submit through that feedback form, and let us know what it is you're referring to. I think I understand you're saying the date's updated frequently, but it's truncated to a precision of 1 week is what it sounds like. So go ahead and submit some feedback about that, and we'll take a closer look at it. Okay, and next up, we had a question come in. Well, actually, this one is related to the last one, so let's go with it first. So Andrew had also asked, where is the neglected variable list? Mark, is that something you know?
No, that would be a George question.
Okay. All right.
As I said, I've concentrated on the alerts. That's where all my efforts have gone. That's where how I've learned all this stuff is concentrating on the alerts. The other lists of data I've really spent very little time on, other than how to get the data. But what I do with the data is just looking at the alerts. So there's a whole lot, it's a great big can of worms. It's a big rabbit hole to go down, and I picked one particular part of it and gotten very good at it, but I haven't become an expert at some of these other lists. Like some of those lists I've never even looked at. The high energy one, I've never even looked at that list. I don't really even know what that means. So.
Okay, well, that sounds like another good thing to reach out with, like a general contact to the AAVSO then to get an answer about. Unfortunately, I'm not sure where the neglected variable list is either.
I know where the neglected double stars is, but that's not at AVSO. That's someplace else.
Gotcha. Okay, so moving on to the next question. Patrick Kavanaugh asked, on the Target Tool's main console, Mark had mentioned there's a blue button and a red button. I'm looking at that page and I don't see either. Could you please point it out?
It was 2 blue buttons, and we see here on the very. Can you see my cursor?
Yes, your cursor shows up.
There's one on the left-hand side and the one on the right-hand side. So if I click on the one on the left-hand side, I get the star information. And if I click the one on the right-hand side, I get the actual alert notice. So it's 2 blue ones, not a blue one and red one, but these 2 here. And if I come up here and type, which database I am, if I type 831, hit return, it will search for it. Now I've got that. And I can now find that one. And that you see here, it also says alert 796. As a point that I forgot to mention, if we go back to my program, I think there's over 1,200 or 1,300 alerts currently. But if you look at my list here, it says, I don't know, hopefully you can see it down at the very bottom, it says total stars 367. Well, where'd all the rest of them go? A lot of times there's multiple alerts over time for the same star. And since I'm plotting them on the screen, I keep track by star name and the most recent alert number. So sometimes alert numbers will be missing because they got overwritten with other alerts. And I think this 796, I think that's one of them. No, it's there as well. But there's a lot of times there's multiple alerts for the same star, but it's these two blue things I was talking about.
Okay, thank you. All right. So let's see, next question here. This one comes from Alan Bedard, who asked if you could please share again the link to your planetarium software, Alpaca Pi.
It's actually real simple. GitHub/msproul, MSPROUL.
Okay, here, I'll type that into the chat so that people can copy it down.
And I can bring up the. There we go.
All righty, thank you.
And on my software, if you decide to use it, like I said, it's Linux based. I support it completely free of charge. It's all open source. I worked with one guy in Great Britain that did a custom roll-off roof for it because it supports all the devices ASCOM supports, such. And I've worked with another guy that has contributed, and we did a servo dome driver instead of a stepper dome driver. So and I welcome contributions as well. So if you've got something special, if right now working with somebody that's got a QHY camera with a GPS in it. He sent me the camera so I can add support for the GPS. I already had support for QHY cameras, but he needed support for the GPS built into it. So he sent me the camera, and I've got that. I got it, I think, on Tuesday, and I've got it basically done already.
All right, great. Okay, so we had several comments come in from George, since we had some questions earlier that he was able to answer. So I'm going to go ahead and read those out at this point. So going back to that question, I believe it was Andrew who had asked about the target tool saying that the last observed date is a week ago, even if it's more recent. George says that it should be quoting the time of the last observation in hours or days if appropriate, and that last observed date is updated every day. So that should be how it behaves. I know that in the past there were some issues with the target tool because it wasn't on our servers. It has since been updated. It has been migrated to our servers. So hopefully that sort of issue is not happening anymore. If it is, then go use the feedback form for sure. George also wanted to clarify that I said that he's a developer of the target tool. He is the maintainer of the target tool. Way back in the day, the target tool was originally authored by a team at Vanderbilt, led up by Dan Berger. So just to put that out there, now the torch has been passed to George, and he's doing a great job of maintaining it. Okay, and moving on to our next question. So Andrew has asked, I am not a programmer, but I will want to automate my observatory in a couple of years. Do I need to know programming in order to use your tools?
No, you do not. Now, just clarify, my system is not automation, it's remote operation. And there's a huge difference between the two. You have to be physically there doing it. But what I'm going to be working on is being able to operate observatories that are in New Mexico from my home in Pennsylvania. So if you're looking for full automation software, my software will not do that at this point. That's something I plan on adding, but it'll probably be a couple of years before I have that put into it. So it depends on whether you're at remote control or automation. And no, you do not need to you do not need to be a programmer to use my system. You do need to become not an expert, but pretty good at, at least he's halfway decent at using Linux.
All right, thank you. Okay, and next question here. So assuming that within the AAVSO alert system, alerts do eventually expire or are canceled, is this information captured in the target tool, or it's the data that you can get through the API?
Some of them, I don't think they're canceled. I don't think they in the text they have a date on them of what they want. I have not seen an expiration in the JSON data. I don't think there's an expiration time in there. I haven't seen it. We can go back to looking at it. It doesn't really tell you anything about that in this data. So no, I don't think that data is there in the automated stuff. In the actual web page, like this last one, we want this for the observation of a Hubble that's going to happen in 2 weeks. Well, it comes pretty obvious that after that 2 weeks, they don't need that data anymore, but you have to infer that. I have not seen anything for even in the tool at all as far as expiration where it's specifically called out. And George might correct me. I just haven't seen it.
Okay, thank you. Thank you. We actually did get a comment from George while you were speaking. George says that the AAVSO is working towards a regular review and update of the star lists. So sounds like right now, no expiration, but hopefully coming soon, that sort of info will be there. Okay, so our next question here is from Michael Poxon, who says, could you say more about your link to Gaia via SQL?
Oh, I have a whole other presentation on that. And unfortunately, the link to my brother's house is currently down, so I can't demonstrate it. So what I have is remote. My brother does, my twin brother, as I mentioned earlier, he's also into computers. He has a degree in computer science, and he does a lot of database work. And 2 years ago, I was doing a occultation of a trans-Neptunian object, and the reference was a Gaia reference number. So I have heard Gaia spacecraft, but I knew nothing about it. I went and investigated and found the 1.8 billion stars that it was available, and said, how can I access this? And talked to my brother. We put the whole database in, the whole star list into a database, and I can access all of it in about 7 seconds. As you go, let me, again, I can't demonstrate this because I don't have the connection up, but when you zoom in, when you get down to the about, let's see, when you get to this level right here, it takes the 1 degree by 1 degree block and tells the server, give me the stars that are just in there. And it takes about 7 seconds. And the number of stars in a 1 degree by 1 degree block varies from 40 at the poles to over 1 million down by Sagittarius in the center of our galaxy. And it takes about 7 seconds, regardless of the number of stars, to get that from my brother's house, which is 100 miles away across the internet, to get that information, and then plots it. It takes about the same length of time, where if I go in here and type a Gaia star number and hit search, it takes about the same length of time to find that star and display that. I published an article in Reflector magazine in last September about that. And if you email me, I will email you the link to that article. And we'd be glad to discuss it and further and demo it. Actually, you know what? It'll keep on going. Next question. I'll see if I can finagle doing a demo of it.
All right. Okay, so the next question which we had coming up, oh, so this one is from Aries Aquaria, who asked, wouldn't it be nice to have an option for BE stars listed on the AAVSO Target Tool's first page? I feel like I can answer that by saying, yes, that would be nice. You should suggest it. But Mark, if you have anything you want to add, please feel free.
No, I don't even know what that is, but I would agree. Yes.
Yes, yeah. If any of you guys have suggestions for, there's specific types of targets that you want to be able to filter in the AAVSO Target Tool, use the feedback form. Definitely do that. All right. Okay, and it looks like we're caught up on questions for the moment, so I'll give you a minute to, if you want to try your demo of this.
Are you seeing my screen okay?
Yes.
All right,
Yes, we
now
can see
let's see if this works. Yes, it's working. All right, what I've just done is I've done a VNC connection into my brother's house, and I've started my program on a Raspberry Pi running my brother's house, because it's at his house, it's going to work. And I just did a search of M31, and I'm now going to zoom in to M31. Let me turn off this. And when I get below, I'm going to turn that off. When I get to there, it now sending out the request. See in the green, set request. And there is the Gaia data populating that quickly. And this is running on a Raspberry Pi via VNC.
Very cool. Wow. All right, thank you for sharing that. So going back to the last question, the one from Aries about BE stars, we did have two very useful comments come in. The first is from George Silvis, who says that you can filter on variability type in the target tool. So put BE into the filter box, and then you'll get a list of the BE stars.
To have George tell me where to do that. Which column?
I'm assuming it's the variability type one. See, the top two are labeled EP for exoplanet. So that would be the fifth from the left column.
1, 2, 3, 4. 1, 2, 3, 4. Variable type. Okay, type in BE. And which one do I need for X? What thing do I need to collect up top? What category?
So I will give George a second to answer that, but I just click on all.
All apply.
Yeah, George says it's best to select all when you do this sort of thing. All right.
And now.
When he wrote down BE, he wrote it in capital letters, capital B, capital E. I believe that's how it's specified in VSX, so it's probably important. George says, wait for the all filter to finish before you search on BE.
Okay. All right, now type in BE, hit return. There, was that it? Yeah.
There you go. All right. So there is a star. It's evidently got several listings in there, BBRI, Biz. Okay, cool. All right, so there we go, Aries. That is one way that you can go ahead and filter on BE stars within the target tool. We also had a comment come in from Mike Powell, who said that you can use VSX and filter on BE stars. So that would be outside of the target tool. If you're just in general looking for BE stars to shoot, of course, the ones on the target tool are going to be the highest priority because there are alerts out for them. But if you want to find some more, then go to VSX and do the same sort of variability type filter, and you'll get a pretty complete list of all the BE stars that we know about there. So great suggestion, Michael. Thank you for sharing that. All right. Let me see. So we have a question from Alan Bedard, who asked, can I search for a range of values within the target tool?
That's a George question.
All right. We'll give George a second to answer then.
Just again, I have not used the web interface very extensively. I've used the programmatic interface quite extensively, obviously, but my use of the web interface is just basics. So how to get around and find things and how to search for alert numbers and things like that. But overall, I pretty much use my software to get the alert data, and I've not gone into the deep end of a lot of these other things.
Okay, so we got a response in from George to that question. He says, right now, it's not possible to set a range. You can just, right now you can sort. So that might help, once you do your other filters, the specific filters that you can do, then sort on whichever column it is you're looking for specific values like maximum magnitude, and just scroll down to when you're within that range. But you can't explicitly set a range in the filter box at this moment, unfortunately. Okay. He says that you can do one of these sorts by clicking on the column title. All right, have we got any other questions? I'm going to tab over real quick and take a look at Facebook and see if we've gotten any on the live stream over there. Don't want to miss anyone. Okay, no questions on Facebook. And no questions back on Zoom. So I think that's a sign of a presentation very, very well explained. I have to say, you're remarkably thorough, Mark.
This is
All
just,
right.
I just switched over to another ME 101. You see how fast it's coming in. And if we zoom
Oh,
in,
yeah.
so let's zoom way down into here and see what happens as we get. So as we get, really down far, we get the information, the Gaia number, the magnitude, the spectral type.
Very nice. Yeah, that's a very useful program. Just as a reminder to everyone who's watching, I did put the link into the chat. In fact, I'll copy it over for our viewers on Facebook. So that GitHub link, which I shared, has as both, there's a repository that Mark has made for this software, but he's also got a repository on there for his target tool related scripts and this presentation. So if you want to reference anything from this presentation, that's where you should go.
And my email address is all over the place. So on this, again, GitHub Sproul. The AVSO is what I've done on this, including today's presentation, both PowerPoint and ODB, which is Linux open office format. And this Alpaca Pi is the full source code to the program that I just showed you. And the Gaia SQL is the reference site for the information about what we did for the publication. Again, it's the September last year of Reflector magazine, which is astronomical, what's it called? Astronomical League. In their publication. Also, my email address is everywhere in the presentation and such, and on the GitHub page. You're welcome to email me about any of this. If you do want to use my programs of any kind, just and need help, I encourage you to email me, and I'll be glad to help you. Let me show you what's in here. We've got the two different versions. We've got a placeholder. We've got my script, and then you have to put your token in here that you have to generate. And then my script is actually it's over 100 lines long. It'll even compile that replace program automatically, and then it pulls everything down using here's the curl command. And where's the, and it will just do all of this. And let me go demonstrate how that works. So I'm in my directory. I say /git sh. There, I just pulled all the data back, and I pulled two versions down. I pulled down the alert version, and I pulled down all versions. So now if we see that there's this is the alerts, and this is everything. And that quickly just pulled it down. And not only did we pull it down, we ran it through this program called replace character and line feed, which adds the line feeds to it to make it look good. So now we have it as of September 2nd at 2:55. We have the full list.
All right. Very nice. That's a really great resource that you've made available to people there. Thank you, Mark.
You're welcome.
Okay. We don't have any more questions, so I believe that's it. I'm going to go ahead and take the screen share back unless there is anything else that you would like to share before we close.
Nope.
Okay, then here we go. All right. So, first, I would like to extend a heartfelt thank you to you, Mark. Thank you for sharing your time and knowledge with us today. This has been excellent.
Thank you.
And before we close out the webinar, I would also like to thank again our series sponsor, Boyce Astro. The Boyce Research Initiative and Education Foundation provides online astronomy education, observatory resources, and research experiences to students, student teams, and schools in order to learn how to perform observations, conduct research, and publish their results in scientific journals, such as the Journal of the AAVSO. Please check out their webpage to learn more about their work. I would also like to thank everyone who's here in the audience. Thank you for joining us during today's webinar. Your questions have really helped to make today's session into something special. And even more than that, it's your participation in all of our programs, your valuable feedback, that allows us to keep growing, keep educating, and keep making an impact on variable star science. So thank you, each of you. We're so grateful for your support. Today's broadcast has been recorded, and if you would like to go back and reference any part of this presentation, you can find the recording right this moment on our Facebook page. Quite soon, we're also going to upload it to our YouTube channel, where it will join our rather enormous library of educational videos. You can find our library on YouTube by searching for the username AAVSO HQ. Now, when you log out of today's webinar, be advised that you should be automatically shown a survey. It should just pop up in your browser. I would really appreciate it if you could go ahead, fill out that survey, and let us know what you thought of today's session, the return of the how-to series, and let us know what you think we can do better next time. Okay, to close, I would like to express one last huge thank you to Mark Sproul from all of us here at the AAVSO. We appreciate you.
You're welcome. It was my honor. I'm privileged.
All right, see you all next time.